Thanks for joining me for this TypeScript tutorial. This will be a hands-on demonstration of how you can get started with TypeScript. Because you're here, I'm assuming you're a programmer with JavaScript experience wanting to take advantage of TypeScript to write better code, or that you are an OO programmer wanting to get serious about JavaScript front-end frameworks or Node.js. We're here at the TypeScript homepage just to let you know where to get started. The documentation page, which is quite extensive, it will take you through how to get up and running, installing TypeScript using an npm package, building your first TypeScript, and doing annotations. It's really quite good. These examples are great and pretty spectacular, so you should really look at these yourself after this tutorial. The download page is a quick reference for installing TypeScript using npm, but its main purpose is to provide you with links so you can download the IDEs that support TypeScript. So you can see that there is Sublime, Atom, WebStorm, those things that you're probably using for your JavaScript development. But if you're coming from an OO background, Visual Studio and Visual Studio Code both support TypeScript natively. And you'll find there's quite a few good features built into Visual Studio for supporting it within MVC frameworks and Web API. TypeScript is an open source project, so you can contribute at GitHub. You can find out other things that are going on through the Friends of TypeScript group. You can also look at the Definitely Typed project, which helps with the frameworks that you are used to using in JavaScript. And there's also Stack Overflow, so good resources there. The TypeScript Playground is a fully featured, highly functional editor that you can use just in your browser. If you had no other tools at all, you could use it quite easily to produce JavaScript for your projects. There's a small demonstration at the end of the video to show you how you could do that. Obviously, it's not the recommended way to do it. There are a lot better tools that you can use on your desktop, whether that's Linux or Mac or Windows, for editing TypeScript. In the tutorial today, we'll be working inside the playground, and the playground will create some data. We'll create an API to work with that data, and we'll write some test cases that we ensure that our code that we've written is working as we expect. So just a brief intro into the playground itself. So on the left hand side we have the area type, the TypeScript. In the right hand side is where JavaScript is created automatically for you, or transpiled from TypeScript into JavaScript. So there's nothing you have to do, it'll just automatically happen. Let's create our model. So we're going to create a class. In the class we call stock item, and that's going to have a name of type string, a price, which is a number, and GST or the tax, which is a boolean yes or no. If you notice on the right hand side we do have stock item created, but there's no properties there. The reason is we haven't actually done anything in the TypeScript side yet with those properties, so they don't appear in the JavaScript because they wouldn't be used at that point. They are good for us because we want to define and give our editor some help whether or not a particular property exists, so that we can use it and get IntelliSense and drop down lists and those kinds of things. So that is the advantage of it. So obviously we can't create this whole application in the short period of time that we have for this demonstration. So what we'll do is create a mini test framework, a very basic one, where essentially what we want to do is create a function that accepts a test result and returns a pass-fail message as an HTML object, so we can output it onto our web page. So we're accepting test passed as a boolean, and we're going to return a string result, which will be the HTML code. So if the test has passed, we're going to return a span where the style color is set to green and says yep, that's passed. Okay, and if we want to then return a failure. Just copy that code and replace the green with red, and failed. Okay, just fixing up my end, making sure I've included my line endings correctly and tidying up the formatting. Right, next we actually want to produce the output for our test result. So we're going to use the HTML document write function, and first we'll output a title of price list test cases. Ooh, and just because we've got a class name there, we'll actually make sure we get the class name right, and we'll close up the H1. Oh, we're getting some warnings that I haven't done it right. Okay, that's better. Alright, so the write function accepts an array of parameters, so you can just continuously keep adding test cases. So that's what we'll do. We'll actually now add a function that returns a string, so obviously that can output. So a function accepting a test or test description, if you like, of type string, returning a string, and in that we'll actually do our test. So we want to return the test description plus colon plus our pass or fail test, and the test will be that price list has an item called banana. Okay, that looks fairly good. I've got an extra brace there, not quite sure what that's for. Alright, we'll say price list should contain banana. So again, I've still got a missing an unpaired brace there. Where's that's coming from? The editor will actually help us find that. Okay, it looks like that one's just extra on the end, so I'll get rid of that. Okay, so that's our test framework in place. Now we can see just below the arrow there, you can see there's a red dot. Now that indicates to us that we actually still have a problem. So the TypeScript is telling us, without running it, that this isn't going to work. So on the JavaScript side, of course, there's no clues. You couldn't ever, that's one of the issues that we're trying to solve with using TypeScript. In fact, that we can tell before we even compile it, before we even run it, that there's going to be a problem. So the problem is, see that is okay, let's try and run it and see what we get. Of course we get nothing because TypeScript told us it wasn't going to work. So do F12 to get developer tools, and the developer tool console tells us there's an uncaught exception, price list is not defined, which we can see because there's a red squiggly under it. So TypeScript giving us that clue that it doesn't exist. So we'll create one. We'll use the let convention here, which is the block aware version of var. So it just helps us with our scope. We could use var, but we'll use the let keyword instead. So we're going to create a price list which is of type price list, capital price list, which accepts a list of prices in our format we've already agreed, and we can see there's a red squiggly under price list. Even though we've created that class, we're not going to be able to we're not going to get any result here. However, just to be clarify, we are using a static array here. This is for debug purposes only. So I'm just going to leave a to do here for me to say that obviously we will be wanting to get prices from a web service or from a web API rather than the instantiated class. But because we're doing our test framework, we couldn't really be sure what content of the array would be coming back. So to ensure our test cases work, we'll use a static variable called prices, just to make sure that our test cases work. So this is the JS doc format, which you could read about yourself outside the tutorial. So now let's look back. So we've still got our red squiggly. So it's saying price list, cannot find price list. And that's because I've got the case wrong, so it should be price capital list. So my camel casing is not quite right. Actually, sorry, this is Pascal case for anything you want to new up should actually be a Pascal case, capital P on the front. Otherwise, similar to camel case, except the first letter is capitalized. So we need a constructor that tells us how to construct price list, a price list class. So we want the constructor to accept something called prices. But what format is prices? Because we've got TypeScript, we've already defined that stock item is the object that we want to deal with, but in fact we've actually got an array of stock items. So we'll use the TypeScript format, sorry, the JavaScript format. This is not TypeScript, this is the format for JavaScript. The array saying, sorry, that's wrong. Yeah, sorry, the array of stock item is TypeScript. So normally in other languages like C# or whatever, we would create a private member called prices and assign that's typed to an array of stock item, which is pretty good. If we then assign it to our internal copy of prices, then we can refer to it later. And so we can use it in our class as an object. So if you look on the right hand side of the JavaScript, we can see this.prices equals prices, but JavaScript actually has quite a neat bit of syntactic sugar that allows us to just replace that rather duplicated code there with the public keyword, which does that automatic member assignment for us. So you see that if we just say constructor public prices array of stock item, it will create the private member for us automatically. So some people like that, some people don't. It's perfect. It's entirely up to you which way you want to go. We're still showing a red squiggly, which is saying, oh, price list does not have a method called hasItem. So we can just move on to that now. HasItem is our function. Notice we don't have to prefix it with function or anything like that. We just say hasItem, which is a method which returns a boolean type. It's complaining it's got red squigglies there because we haven't actually returned anything at the moment. But we're going to accept an item name to search for. Again, it's still complaining that we haven't returned anything, so we better return something. So function whose declared type is a blah. We need to return the type that we say we're going to return. So if we just return a false, we now have a clean slate, no red dots indicating a problem. So in fact, TypeScript is telling us this will run. May not give us the result we're hoping for, but it will run. So yes, it does, and it returns our first failed test case. And because we're using TDD approach, test-driven development, that's exactly the right outcome. So we want it to fail first, fix up the code so it just works, and then move on to the next test case. So that's what we'll do. We need to next work on how we're going to return that value. So we need a function that's going to iterate over the array and locate the object that we're looking for. So we're going to locate it by name. We want to return the whole object, not just a reference to it, so because we would need that later for other functions. So if we now look at the prices array, that's the original one, not the internal one, you see there's a lot of JavaScript functions now that are part of the array. Now, one we're looking for initially is the find one, and you can see on the original array it's very verbose. It actually has a copy of each one of the elements in the array. But if we go and now look at our local copy of that, the this.prices array, you'll see that if we go to find again and we look at the signature of that call, we'll see it's a lot cleaner. It's accepting a predicate or a function value containing the stock item as one of the values to pass in. You can optionally accept the index as well, and returns a boolean, and the whole thing returns a stock item, which is the thing we want. So we're going to find a stock item such that, or using the lambda expression or the arrow function expression, we could create a mini function inside here and say stock item dot name equals the item name, so that returns our boolean. So if we said return stock item name equal item name, that will give our boolean result that the predicate's looking for. However, because again there's a lot of syntactic sugar here, we can actually use a shortened version of this, very similar to C#, for those who are familiar with lambda expressions in C#. In fact, it's identical, same architecture. So we're going to actually return now the whole stock item back to our function. Now we'll just test that we haven't broken anything. We're still getting the one failed test case, which is good, but at least it's still functioning. We will use that because there's no red indicators. Now we want to use the function, so we're going to know we're going to use locate item somehow. In the wrong format, of course, is returning the stock item and not a boolean. So if we say item name, Typescript is telling us, okay, this is not the right return type, so we've got to turn this into a boolean. Whoops, I'll just put that back. Okay, so we're returning a stock item. That gives us our object, but it's not a boolean. So we want to turn this returned object into a boolean by making using the not expression, and unfortunately that will give us the wrong outcome because we want the not. So the JavaScript not function is quite a common thing in JavaScript, as you probably know. So if we now look at it, we're now getting a passing first test case. So that's pretty good. Now, next thing, you probably noticed I've taken a bit of liberty here with the editing of the video. I actually had to go fix up the way that the screen was displaying. That was a little bit too small, so I've just off screen fixed up the format there so it makes it a little bit bigger. So I wasn't doing anything too magical, just made it look like that instead. Okay, so back onto the discussion. So now we want to actually add a new test case. So firstly, this was the happy path. So what would happen if we passed in something that didn't exist? So we'd expect that we'd get a false on our HTML has item. Sorry, a price list has item. Our price list has item. So I'll just try and tidy this up a bit, make it easier to cut and paste. So now we want to say, okay, what if it's an orange? So we want it to fail if we pass in orange. So obviously there's no oranges in the list. So the price list should not contain orange. Now I'm going to need to tidy up the test framework a little bit because it's a little bit annoying to have to keep fiddling with the commas and whatever. So I'm just going to add a bit of extra, just a do nothing statement at the bottom so I don't have to keep adding commas and fiddling around with that last field. So I'm just going to add a permanent empty field at the end so that now when I copy and paste I can just copy and paste each test case with a comma on the end and I don't have to fiddle with it. Just a bit of makes the cases easy to work with. So if we run that, we've got a good, ooh, whoops, that's an unexpected result. I expected that to pass, but I've obviously done something wrong here. Yes, I need to say not. Yeah, in our test condition we actually need to say should not exist, and now we're passing, so that's good. So now we want to move on to the next test case. We want to return an actual value from the array rather than just a boolean. So this time we're going to say milk should cost $1.99. If I my memory serves. Let's just go confirm. So instead, sorry, we can't use has item here. We're going to need, we can just use the locate item directly, I think, here. So we'll use locate item to return the milk object from the array, and we want, just tidy this up a little bit, and we want the prices. Okay, we want the price. So does the price equal 199? Oops, that should be double equals or triple equals. And I've also got a boolean there, which makes it a bit confusing. Still got the boolean. Yep, the wonders of cutting and pasting. So let's tidy that up again. We'll fix that up. Okay, now we're making some kind of sense. Okay, that's our test case. Milk should cost $1.99. Let's run that, which it does indeed cost $1.99. Again, we're using TDD here, so we're just going for the minimum to make the code pass the test. We're going to need to change that. We can't be using that whole locate item function within our test cases. So next we'll just move on to our next test. The next test is a pie should cost $2.64. Now this one has tax on it, so we can't without a whole lot of fiddling use that locate item. That'll just get too cumbersome in the end. So I think what we should do is we should make a new function, but we'll just make sure this still works this way. So obviously a pie should cost $2.64 should not pass there because there hasn't got the GST component. Okay, so we're going to make a new function now called price of. So let's make a price of function which accepts item name again, just searching by name, returns a number this time. Remember, that's a JavaScript number. It's not anything TypeScript has defined, so it's normal JavaScript number. We want to return the located item's price. And again, that's the minimum change. And now we have to go back and check milk. So the price of milk should return $1.99, and we should still get a passing test in this case, now that we've changed out to a new function, because really we've just done exactly the same thing, we've just done it in a different spot. Okay, but of course that's still not going to help us with our milk problem. So we're going to update the price, not the milk, the pie. Our pie needs $2.64, and we haven't done anything about the tax there. Again, just checked it was still failing. So now we'll go back to our function and implement the tax part. So I'll just have a quick think about it. We'll just refactor. So we need to start with a price and end with a price and return that price. So the price would be the default one, some kind of number. We want to return price eventually. Now what are we going to do to the price while we're working on it? We're going to get the stock item by using the locate item function, which is what we were doing before. And if we successfully get it, we want to work on it. So if stock item exists, i.e. not null. Oh, that of course, if we have is a null, that's going to cause us a problem, so we better call that equals 0. So if it doesn't exist, we better say it's 0. So now we need some kind of factor to work on our GST, so it's either going to be 1.1 or 1, depending on whether this tax available or not. So tax at 10%. So if stock item GST, and we could have used a ternary here, but some people don't like them. I quite like them, but we'll go with make it looking a bit simpler. So let the factor equal 1 unless it's got GST, in which case the factor is 1.1. Now we get our price, multiply it by the stock item dot price, and multiply by the factor. So that should theoretically give us our answer. Now just back on the let statement, so you see, because it's got blocking scope, if we look at factor, which was defined inside that block, TypeScript says I don't know what that means. So it's just to let you know that the factor is actually does have a blocking scope. So now our test case passes at $2.64. So we'll move on to the next test. So now we want to test again, the sad path. What if something doesn't exist? Should do a test case which shows that we return 0 if something doesn't exist. So again, we'll use oranges, which we know don't exist, and should equal 0. That was our default value for number. So an orange should cost nothing. And nothing dot nothing. Okay, so that test case should pass immediately. Got everything right? Yep, which it does. So oranges cost nothing because it's not in the list. Now, so the next lot of functionality is what if we've got more than one item. So if you put 2 bananas, say. So let's have a test case that says 2 bananas should cost twice as much as 1. So I think they were 25 cents. So we'll just make it 50 cents. So we'll just go check. Yes, price of bananas are 25 cents. So 2 of them should equal 50 cents. So okay, so how are we going to do that? We should have an alternate parameter put in there, so we can say 2. But we need to make that an optional parameter because the other test cases will all fail there if we strictly require that parameter. So we're going to need an optional parameter this time of count. You can just use the question mark colon syntax. So question mark number. So, and how are we going to apply this? Again, JavaScript gives us some great syntax to help us here. We could work on factor if we wanted. If something, then do factor times something, but in fact it's easier. We can just do it pretty well in line using the not exist functionality within JavaScript. So we can say if count exists, use count, or use 1 if it doesn't. So count or 1, and the double pipe is the syntax for or. So theoretically we should have a passing test case now, except, oh yeah, better put 50 cents on there. So it should equal 50 cents, and that should now pass, which it does. So it makes me feel good. So next, obviously, we've got the we want to just check and make sure that, oops, it failed this time. That's because I don't think I quite got the test right. So 75 cents, and we need 3 bananas if we're going to test for another number. Okay. Right here. So 3 bananas should cost 75 cents. Works as well. So that just proves I haven't done anything magical there. Now finally, obviously, if we're going to check for something that doesn't exist, we want to make sure that we've got the sad path covered. So So 3 oranges should cost nothing. 3 oranges should cost nothing. Right, that should cover our sad path for that as well, just to make sure our test cases are all complete. I think that proves it. We're all good, so we're pretty happy with our API now. Next we want to consider what we're going to do with this API. So we have two parts, the HTML part and the API part, which is up here. So what are we going to do with it? Let's go over to another page on Chrome and go to the developer tools. That's just F12. So we'll just zoom up a little bit here. So I've gone to the sources tab in the developer tools, and I've gone to a folder they've already made called JSDev. Now I'm going to create in there a new file called pricelist.js. That'll hold the API part of the JavaScript code we just created using Typescript. And I'll create another file for the HTML part. So we'll have a mini web page that just implements our pricelist API to run our test cases. So in the pricelist.js, we'll just flip back over to the other page, grab out the API part, which starts down there all the way up to the top, and we'll paste that in. So this is actually a fully featured editor also that's just inside Chrome, so there's all the features you expect. So let's just save this file. If you right click, should get a drop down list of things. So like save, lots of other things in there as well. It's just a little bit small to work with, I've found, so there are better tools for doing that, but we'll work with this just out of the box, so you don't have to install anything. Now let's go to our HTML page, start writing our markup. So we need HTML tags to hold our page, the body, we won't worry about a head, and in there we're going to need some script files, so we're obviously going to need to import our pricelist.js, and then we'll need a section for our HTML part of our script to run that contain our test cases. So we need another script tag, type JavaScript, and we'll close that tag. I'll pop back over and get the HTML part. Well, it is a JavaScript type part, but it's going to be in our HTML page. Copy that out, flip back over and paste that in. Now theoretically that's pretty much all we need. Okay, let's save that. It's one of the confusing things about Chrome, the developer tools, if you've just experimented a little bit, you actually get extra tags, which is copies of the pages you've already looked at. But anyway, well, I've saved it now. You can also do things like evaluate though, so you can see that that's actually going to run. If we ran that, it actually looks like it's going to run. And we'll just save that. And let's open up that in our browser, and we get nothing. Okay, so it did run, but there was a problem. Let's flip back and see what the problem is. Unexpected token. Oops, I probably missed closing a tag or something. Let's have a look. Yeah, that line there is line 4, but the line above doesn't have a close script. So let's close that off. And I see my old problem, a problem I always have. I forget that the source should actually be src. I'm used to typing out long long names for commands, so I'll just fix that up. It's src. So that's probably likely to work much better now. So let's close up what we don't need. Again, that's Chrome helping us, but that's an old copy of the page. We want to go back down to where our original, where our code is, and run it from there. So let's view that. Then we'll flip back over, and now we see we've actually got all our passing tests in an actual page, and there is our JavaScript and HTML source.